Okay, this video is on factorial notation. Factorial notation is just a type of calculation that you use in different situations, including situations involving permutations and combinations. So let's take a look at this example. I have 8 books I want to arrange on a shelf. How many different ways can I arrange my 8 books? And we've seen examples like this before. Since I'm arranging a number of items, I know this involves permutations because order matters. And we've already talked about 2 ways that we could go about calculating this number, the number of different ways I can arrange the 8 books. I could just use my permutation notation, my permutations operator in my calculator. And since I have 8 books and I want to arrange all 8 of them, then that would be the number of permutations of 8 objects taken 8 at a time. I can punch that into my calculator and get 40,320. So there's 40,320 ways to arrange these 8 books on a shelf. Another way that I can calculate this same number is I could use the fundamental principle of counting, and if I draw my 8 boxes and I put the number of choices that I have for books to go in each slot, the number of choices I have for this first slot is 8. The number of choices I have for the second slot is going to be 7. And this one's 6 and 5 and 4 and 3 and 2 and 1. And if I take my calculator out and I multiply using the fundamental principle of counting, if I multiply each one of these numbers, 8 times 7 times 6 times 5 and so on, then again I get this same number, 40,320. Well, there's another way that I can do this same calculation, figure out how many ways there are to arrange these 8 books, and that's using something called factorial notation. And factorial notation, in this particular example, I would use factorial notation. I would write this, 8 with an exclamation point. This exclamation point is just called the factorial operator. And anytime you see this exclamation point after a number, after it's this factorial operator after a number, that tells you that you take your number and then you multiply it times the next number down, which in this case is 7, and then you multiply it times 1 less than that, and then you multiply it times 1 less than that, and so on all the way down until you get to 1. It only works with integers. You don't ever have, you wouldn't use fractions or decimals. It only works, factorial notation only works with integers. So 8 times 7 times 6 times 5 times 4, that's exactly what I did here using the fundamental principle of counting. So again, I would get 40,320. So this is just using factorial notation. It's just another way of expressing what we've already expressed here in these other ways. And now factorial notation will work with any integer number. So say if I want to calculate 92 factorial, well, 92 factorial means 92 times 91 times 90 times 89 and so on all the way down to times 2 times 1. All right. So let's see how we would use factorial notation with this slightly different situation. What if I only want to arrange 3 of my 8 books on a shelf? And again, we've seen examples like this before when working with permutations, and we've got our 2 methods that we've already talked about using. I could use my permutations operation on my calculator. If I only want to arrange 3 of my 8 books, then I want the number of permutations of 8 objects taken 3 at a time. And I can punch that into my calculator, and if I punch that into my calculator, I get 336. Again, I could also use the fundamental principle of counting. Since I only want to arrange 3 of my 8 books, I would draw 3 boxes, and I put the number of choices I have for the number of books that could go in each slot. And for my first slot, my number of choices is 8, second slot it's 7, third slot it's 6, and I use the fundamental principle of counting and I multiply these 3 numbers together, and if I multiply those numbers together, I get 336. Well, I can also express this answer, I can express this operation using factorial notation. And the way I would express this using factorial notation would look, actually before I write how I'm going to express it, let me write this over here. If I were to take 8 factorial, notice that the way I calculated this using the fundamental principle of counting, it looked like I was about to start, it looked like I was about to calculate 8 factorial. It looked like I was about to say 8 times 7 times 6 times 5 times 4 times 3, except I got to 6 and I stopped. It's like I chopped off everything after the 6, right? That's essentially what I'm going to do. If I took 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and notice that if I took this value here, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and if I divided it by 5 times 4 times 3 times 2 times 1, then all of these numbers would cancel out with all of these numbers. In other words, it'd be like taking 8 factorial and chopping off everything after the 6. Well, this is just 8 factorial. That's what this number is. This number here, 5 times 4 times 3 times 2 times 1, that number is 5 factorial. So I can express this 8 times 7 times 6 as 8 factorial divided by 5 factorial. Well, what I've actually done here is shown the formula for permutations. And in fact, if I take my permutations formula here, the permutations of 8 taken 3 at a time, I can write this as 8 factorial divided by 8 minus 3 factorial. In other words, the number of permutations of 8 objects taken 3 at a time means I'm going to take what's on this side of my p, this number here, I'm going to put it in my numerator and factorial it. Then I'm going to take both of these two numbers, the 8 and the 3 in this case, and I'm going to put them in the denominator like this, 8 minus 3, and then I'm going to factorialize this number in the denominator. And so what this gives me is 8 factorial divided by 8 minus 3 is 5. 8 factorial divided by 5 factorial, which is this number, 8 factorial, with everything after the 6 chopped off. This right here is the formula for a permutation. And so if we want to calculate, typically you see this written like this. In fact, on your calculator, when you look at the permutations operator in your calculator, it looks like NPR. This is the number of permutations of n objects taken r at a time. And that formula is just n factorial over n minus r factorial. In other words, you take whatever's on the left side of the p, that goes in the numerator with a factorial operator. Then you take both numbers and you say n minus r, in other words, this number minus this number in the denominator, again with a factorial symbol. So let's take a look at how we can use this that we've learned about factorial notation to solve some of these problems right here. So we want to calculate the value of each of these expressions. Now, at first glance, it looks like, well, you know, this shouldn't be that hard. All I need to do is take my calculator, punch in 120 factorial, and then punch in 116 factorial, and then just divide those two numbers. Except, and I encourage you to try this, if you try this, you'll find that it's not that easy to do, because if you type in 120 factorial, your calculator is not going to be able to calculate that number. It's too big. One of the things you learn when using factorial notation is that the numbers get really big really quickly. So you can't just type in 120 factorial into your calculator. You need a different method. Well, turns out that we have a different method. I'm going to take 120 factorial and I'm going to write it out. I'm not going to write out the entire thing, but I'm going to write out a little bit of it. 120 factorial means 120 times 119 times 118 times 117 times 116 times 115 times 114, and I'll stop right there and just say the rest of it just goes all the way down to until we get to 1. Divided by 116 factorial. And I'm going to start this one over here, and you'll see why in just a minute. 116 factorial means 116 times 115 times 114, and so on. Now, notice that if I take this number here, 120 factorial, divide it by this number here, 116 factorial, notice what happens. everything from here on down, 116 times 115 times 114, that cancels with what's in the denominator. So what I'm left with is 120 times 119 times 118 times 117, and that I can punch into my calculator, and I get 197,149,680. Let's try example number 3. I'm going to use the same trick here, this same technique. I'm going to start out by writing 76 factorial in the numerator. So 76 factorial is just 76 times 75 times 74 times 73 times 72. 73 factorial, and again, let me start over here, is 73 times 72, and on down until I get to 1. And you can see the reason I'm writing it over here is just because it makes it clear this is what I'm canceling out. Everything below the 74, 73 times 72, cancels with everything in the denominator, which simplifies my expression. Now I just have 76 times 75 times 74, and if I punch that into my calculator, I get 421,800. Now let's take a look at example 4. Here I've got a factorial expression, but I don't have just numbers, I've got some variables as well. So again, I'm going to use this same technique, except now I'm going to be using variable expressions instead of just numbers. So once again, I want to write out this expression, and hopefully after I write out some of it, I'm going to have something in the denominator that I can cancel out with. So let's see, now in factorial, it means the same thing as any number factorial, which is that I have to multiply n times the next number down, or the next number 1 less than n. Well, 1 less than n is n minus 1, and then I have to keep going. 1 less than n minus 1 is going to be n minus 1, which is n minus 2. And then the next number down is going to be n minus 2 minus 1, which is n minus 3, and so on. N minus 3 factorial means n minus 3 times 1 less than n minus 3, which would be n minus 3 minus 1, which is n minus 4, and then that's n minus 5, and so on down. And you can see what's happening. This cancels out with this, and what I'm left with is n times n minus 1 times n minus 2. And I'm just going to leave the answer in this form. Some people will go ahead and multiply this out and get a third degree expression, but I'm just going to leave it as n times n minus 1 times n minus 2. Notice that I don't have a factorial symbol in my answer. The factorial has gone away when I canceled out my numerator and denominator pieces. Same thing up here. I don't have a factorial in my answer. All right, let's take a look at this last one, example number 5. Calculate the expression, the number of permutations of n objects taken n minus 3 at a time. Well, I'm going to be using my permutations formula. My permutations formula says that, let's go ahead and write it over here, n factorial over n minus r factorial. So basically all I do is, if I want to put this into my permutations formula, I need to take what's on the left side of the p and put that in the numerator with a factorial symbol, so that's n factorial. Then in the denominator, I want to take what's on this side and subtract what's on this side, and then put a factorial symbol around both of those. So I want what's on this side, which is n minus what's on this side. So I want n minus 3. And since I want to subtract this whole quantity, I need to put it like that. So this is n minus 3. And then I want to put a factorial around that. Now, turns out that I can also simplify this expression, although I'm going to have to do a little bit more work. I'm going to have to do a little bit of algebra here, and I'm going to leave that for you to finish, and we'll take a look at this one tomorrow in class.